Welcome to the testing and certification portion of the VTS. This chapter is an introduction to the starting and charging systems. My name is Lance Wiggins and I'll be your host for this course. It's a great day to fix transmissions, so let's get started. A dead battery is the most common electrical symptom. Always test the battery thoroughly because a reliable battery is essential to the customer as well as the vehicle. Take the vehicle history and current usage into account. If a battery fails the tests, immediately recharge or replace as needed. If the battery tests marginal, immediately recommend a new one in writing if necessary. A weak or under capacity battery also may overheat the alternator and starting systems. You cannot test an electrical system accurately with a weak or under capacity battery. A connectivity test measures the battery's ability to conduct current or electrical volume. Therefore, conductivity is the opposite of electrical resistance. Resistance is anything that opposes the flow of current. Conductivity is a relatively new test technique that started gaining popularity in the late 90s. Today, a variety of automakers endorse this approach. The traditional battery load test is sometimes called an active test because it forces a battery to work. That is, it makes the battery flow a high volume of current. On the other hand, the conductivity approach is sometimes called a passive test because it doesn't force the battery to work. Instead, it basically pulses a signal back and forth through the battery, checking the battery's ability to conduct that signal. Many technicians prefer conductivity tests because they find it accurately tests batteries that are not fully charged. It helps them decide quicker and more accurately if a dead battery is worth recharging or replacing. This saves the time and cost of trying to recharge a battery that is not worth recharging. Battery load tests. Connect your load tester as shown here. Carefully adjust the load knob control until the amp meter reads 1/2 of the battery's cold cranking amps. When in doubt, load the battery to 1/2 of the cold cranking amp rating of the original equipment battery. Hold the amps reading at 1/2 of the cold cranking amp rating for 15 seconds, no longer than that. Hold the load control knob as steady as possible. Voltmeter reading at the end of the 15-second period before releasing the load control knob. Usually a good, trustworthy battery will maintain at least 10 volts. The charging system is a negative ground system with the generator, including an internal voltage regulator, being belt-driven by the engine accessory drive system. When the engine is started, the generator begins to generate alternating current, AC, which is internally converted to direct current, DC. This current is then supplied to the vehicle electrical system through the output battery positive terminal of the generator. Here we'll take a look at a typical Chrysler section. The charging system is turned on and off with the ignition switch. The system is on when the engine is running and the ASD relay is energized. The standard relay is energized when the PCM grounds the ASD control circuit. This voltage is connected through the PCM or intelligent power module, if equipped, and it's supplied to one of the generator field terminals, which is your gen source battery positive, at the back of the generator. The amount of DC current produced by the generator is controlled by the EVR, field control, circuitry contained within the PCM. This circuitry is contained in a series with a second rotor field terminal and ground. The ambient air temperature sensor is used to calculate the temperature near the battery. This temperature data, along with data from the monitored line voltage, battery voltage sense circuit, is used by the PCM to vary the battery charging rate. All vehicles are equipped with an onboard diagnostic system, so all OBD2 sense systems, including the EVR, which is your field control circuitry, are monitored by the PCM. Each monitored circuit is assigned to a diagnostic trouble code. The PCM will store the DTC in electronic memory for certain failures it detects and illuminates the MIL lamp. The ambient temperature sensor is used to control the battery voltage based on ambient temperature sensor. Now, this is an approximation of the battery temperature, but most Chrysler units have this. The PCM maintains the optimal output of the generator by monitoring battery voltage and controlling it to a range of 13.5 to 14.7 volts based on battery temperature. The system target voltage is 13.5 to 14.7 volts. However, the actual voltage may go below this during heavy electrical loads and generator speeds. Also, the actual voltage can be lower than the target voltage between the battery and the battery voltage sense circuit. This will be approximately 0.2 to 0.3 volts. If you have any damage to the charging system, you must fix these first. Charging system problems, especially overcharging, can cause havoc with the entire electrical system. It's not uncommon for an overcharge condition to force an onboard computer to default or go into a limp mode. The result can be some very unusual symptoms and erroneous trouble codes. Furthermore, diode and stator failures can cause electrical noise that in turn upsets sensors or onboard computers. Experience shows that the smartest, fastest, and safest approach is to always test and, where necessary, repair the charging system first. Then, see if repairing the charging system eliminates the vehicle's other symptoms. So the three things you're going to look at for your charging system are voltage regulator, alternator output, and alternator ripples. The first in any step in electrical diagnostics should always be to check the battery and the charging system. This is the source of all vehicle electricity. So a problem here can affect any of the other electrical systems. Start with a visual inspection. Look for damage or corroded battery terminals or frayed or loose wires. With the engine off, make sure that the alternator belt is in good condition and tightened properly. Check the battery and no load voltage. A fully charged battery should deliver 12.6 volts. If it's below 12.4, charge the battery and retest the system. During this test, you should load the battery with 1/2 of its cold cranking amp rating for at least 15 seconds. During this test, battery voltage should not drop below 9.6 at 70 degrees Fahrenheit. Next, you should check the charging system. During this test, you'll check the current and voltage from the alternator during normal operation and under electrical load. In most cases, the alternator should deliver between 14 and 15 volts under normal operating conditions, and can be capable of producing its full amperage during ratings with the engine at fast idle and all electrical systems loaded. Don't forget, check the AC voltage signal from the alternator. Excessive AC can create interference in the electrical systems, triggering the computer to cause erratic vehicle performance. Anything over 500 millivolt AC indicates a problem with the alternator and will require further diagnosis. To test the voltage regulating system, connect the battery to connect the voltmeter to the amp meter as shown. Engine must be warmed up and all accessories off. Hold throttle steady at approximately 2000 RPM. The ammeter reading will drop steadily and then stabilize at some number. The lower the number, the more accurate the test. The voltmeter reading when amp meter stabilizes at the number less than 20 amps. The voltage reading, which should be very steady, is the voltage regulator setting. Compare that voltage regulator setting to the specification of 14 to 15 volts is typical. The engine should be at normal operating temperatures and all accessories should be shut off. Hold engine speed steady at fast idle, approximately 2000 RPM. If no OEM spec are readily available, a good working limit is 14 to 15 volts when the current is at 20 amps or less. Shut off all accessories. The engine should be warmed up and running at a steady, fast idle, approximately 2,000 RPM. Connect the load tester as shown, preferably with the amps pickup as close to the battery positive, or battery terminal as possible. Carefully adjust the load control knob until you see a maximum amp output without allowing the voltage reading to drop below 12.6 volts. Compare amps output to specs. If the alternator produces its rated amps output before the voltmeter reaches 12.6 volts, release the load control knob immediately. The test is finished. The most accurate way of testing your alternator is doing an alternator ripple test. This is used with an oscilloscope. This does require practice and familiarity with your own scope, and practice makes perfect. Some charging system testers analyze alternator ripple and give a go or no-go test result instead of a scope pattern. The test results could be shown with an LED display, an analog meter, or with a red or green light zones, or possibly an alphanumeric message. These scopeless methods are usually adequate, but for best results, always test the alternator ripple with substantial load on the charging system. At the very least, load the charging system by turning on lots of accessories during your test. Alternator connection test. Suppose you're diagnosing a no charge or undercharge or overcharge condition. If so, never overlook the possibility of bad connections or damaged wiring. Also, never assume a vehicle has only one problem in it. Always perform these voltage drop tests with the engine idling and lots of electrical accessories turned on. Pinpoint and repair any bad connections or damaged wiring when retesting or testing the charging system. Never condemn an alternator and or voltage regulator until you have pinpointed and repaired these causes of any excessive voltage drops. Perform all three tests with the engine running. Turn on as many accessories as practically possible. First, connect the voltmeter between the negative battery terminal and the rear alternator housing. A good working limit is 0.2 volts or less. Second, connect the voltmeter between the positive battery terminal and the alternator output terminal. A good working limit is 0.8 volts or less. Lastly, connect your voltmeter between the positive battery terminal and the sense terminal. This is usually labeled S, but terminal A on many Fords. A good working limit is 0.2 volts or less. Many repair jobs require disconnecting the negative battery cable from the engine. Always double check that the negative cable is bolted tightly to the engine before you restart the engine. The engine usually cranks and starts even though the negative cable is loose at the engine. Current takes the path of least resistance back to its source, the battery. Now the path of least resistance from the starter back to the negative battery terminal is through the transmission links or cables, the body, and then through the body ground. Starter ground circuit can destroy throttle cables, transmission floor shifter cables, clutch cables, emergency brake cables, speedometer cables. This current can also damage transmission bearing and driveline U-joints. A scorched or burnt ground wire between the battery and the body and the negative battery terminal is a telltale sign that someone forgot to tighten up the negative battery cable to engine connection. Connect the voltmeter between the negative battery terminal and a clean source placed on the firewall. Start the engine and turn on as many accessories as possible. Again, a good working limit is 0.5 volts or less. Be sure the battery passes the standard test. Recharge and replace if the battery needs to be before proceeding. Be sure the battery cables and connections pass your voltage drop test, and be sure the starter motor control circuit, which is your starter relay or solenoid, passes the voltage drop test. Watch out for engine-related or ignition-related cranking problems, including excessive engine turning effort due to varnish or carbon, excessive effort due to overheating, or excessive effort due to seized accessory components like a serpentine belt or bearing, erratic cranking due to pre-ignition caused by carbon deposits. Never diagnose a starter by hammering it. Safely disable the ignition or fuel system so the engine won't start. Connect the voltmeter between the positive battery terminal and the positive cable terminal on the starter itself or on the starter mounted solenoid. Crank the engine for 5 to 6 seconds. You should see approximately 0.5 volts. Connect the voltmeter between the negative battery terminal and the starter motor housing. Crank the engine for another 4 to 5 seconds. A good working limit is 0.5 volts for each of these tests. Connect the voltmeter between the negative battery cable and the starter solenoid housing. Crank the engine for 4 to 5 seconds. A good working limit, again, is 0.5 volts. This test isn't possible with starter-mounted solenoids. On these systems, the solenoid is grounded inside the starter motor. Connect the voltmeter between the negative battery terminal and the starter solenoid circuit terminal. Crank the engine for another 4 to 5 seconds, and we're going to look again for that 0.5 volt for each of these tests. So this is going to conclude our testing and certification portion of the VTS. We want to thank you for participating in our virtual training solutions powered by ATRA. Until next time, let's keep fixing transmissions together.